Hello, welcome back to Algebra 1. We're continuing to work with powers of monomials, and we're just going to crank up the problem complexity a little bit and also start to work a little bit faster so that we can get a lot of practice here. If you have, for instance, 3 times a squared times b, and you're raising the whole thing to the power of 3, what do you do? Well, this is a monomial with 3 separate entities inside, so this exponent gets distributed to everything. And if you run into another exponent along the way, you just multiply them together. So what you're going to have is 3 raised to the power of 3, and then a raised to the power of 2 times 3 is 6, so that's going to be 6, and then b is going to be raised to the power of 3. So then all you have to do is figure out what is 3 cubed, which is 3 times 3 times 3. It's a to the 6th b cubed. So what this is 3 times 3 is 9, 9 times 3 is 27. So it's 27 a 6th b cubed. That's the final answer. All right, then for our next problem, what if we have 2x squared times 2x to the 4th power? Now don't let this frighten you. What you have is a monomial raised to a power, but then it's multiplied by another monomial raised to a power. So remember your order of operations. I mean, you do have a multiplication between these two, but that comes later. You have to handle all of the powers of the exponents first. So this 2 is going to get distributed in here, and this 4 separately will get distributed in. We'll get all the answers there, and then we'll finally do the multiplication of everything. So what we have is 2 raised to the power of 2 times x raised to the power of 2. That takes care of this. And then it's going to be multiplied by, put a little dot here to make it clear, 2 raised to the power of 4 times x raised to the power of 4. All right? So basically that's what you need to do. Now, what's going on here? We can look at this and we can use some of the knowledge that we have gained from other sections before. The base here is 2, and the base here is 2. So we can just add these exponents. 2 plus 4 is 6. So the same base remains 2. 2 plus 4 is 6, just like this. And then we have the same base here, x and x, so we can carry that through and add those exponents together, x to the 6th power. So you see how we are using multiple things. We know that when we're multiplying things with exponents, if the bases are the same, we can add the exponents, so that's what we've done. Now we need to figure out what is 2 to the 6th power. The easiest way to figure that out is just to write it down, or just use a calculator. 2 times 2 times 2 times 2 times 2 times 2. Make sure that's 6 times, and that's x to the 6th power. All right. Now when you do that in your calculator, or you can just start multiplying. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the answer is going to be 64 times x to the 6th power, and that's the final answer. All right, now our next problem, again, we're just cranking the complexity up just a little bit each time, is going to be a little more complicated. It's 3 times a squared times b, all raised to the power of 3, and then we multiply that times another monomial, 2 times a cubed times b. So you see this monomial is raised to a power, and this one is not. So, and they're multiplied together. So the multiplication here comes later. We have to handle the exponent first. So we multiply the 3, we distribute the 3 in to every term here, or every little object here, multiplying any exponents we get to. So it'll be 3 raised to the power of 3 times a to the 6, because 3 times 2 is 6, okay? And then it'll be b cubed. And then we'll be multiplying this by the 2a cubed b. There's really nothing to do there until later. So now we look at this and try to combine like terms. Try to, or I shouldn't say combine like terms, but look for the same basis so we can simplify things. So 3 is different than 2. We can't really combine those directly. So we need to figure out what is 3 cubed. And you can do that in your head. 3 times 3 is 9. Times 3 is 27. So this is going to be 27 a to the 6th b cubed times 2a cubed b. Now everything's multiplied together. So what is 27 times 2? What is 27 times 2? It's going to be 54. All right, and then we see that we have an a and an a here. Same base, so we can add the exponents. A, and then 3 plus 6 will be the 9th power. And then we have a b and a b, so we can add these exponents. 3 plus 1 is 4, b to the 4th power. And that's the final answer. 54a to the 9th, b to the 4th power. All right, so far things have been pretty straightforward. Even though it's a little complicated and you have to use your brain and think about it, it's been pretty methodical, and we're going to keep it that way. It's always going to be like that. But the next problem is a little interesting because now you have a fraction. 1/2 p squared q, all raised to the power of 3, and then you have multiplied by 2p q squared, all raised to the power of 4. So you see, I told you fractions were going to come up over and over again. So now we have this monomial, which includes a fraction, raised to the power of 3, this monomial raised to the power of 4. So separately, we need to do all of the exponents first. So we'll take the 3 and distribute it into each quantity in here. And we'll take the 4 and distribute it in as an exponent and multiplying exponents as needed, and so on. So when you're taking this 3 and you're kind of applying it to the 1/2, it applies to the 1/2 as a whole unit. So the way you would write it is 1/2 to the power of 3. And I'll show you how to deal with that here in a minute. But for the next term, you have p, and you have 2 times 3, so it's going to be p to the 6th power, and q to the 3 power, because this is getting distributed in here. Now the easiest way to kind of keep it grouped is, let's go ahead and wrap it in brackets, just to kind of keep it grouped away from the next thing that I'm going to be working on, which is this. So we have the 4 going in applying to the 2. So what you're going to have is 2 to the 4th power, and then you have p to the 4th power, and then you have q to the what? 2 times 4, you just multiply them, giving you 8th power. Okay? So at this point, it's nice to kind of like take a little aside here and kind of write down here, what is 2 to the 4th power? It's 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this comes out to be actually 16. And then let's work on this fraction here. We have 1/2 raised to the power of 3. Now when you have a fraction raised to a power, the way you deal with it is the power gets applied to the numerator and the denominator separately. That's how you handle it. So it's 1 cubed on the top, 2 cubed on the bottom. That's pretty important for you to remember. If you ever see a fraction with a power applied to it, it gets applied to the top and it gets applied to the bottom. So what you have is, on the top, 1 cubed is 1 times 1 times 1, which is just 1. And on the bottom, 2 cubed is 2 times 2 times 2, which is 8. So what we figured out by just kind of writing off to the side is that 1/2 raised to the power of 3 is 1/8, and 2 to the 4th power is 16. So now we have enough to kind of finish our answer. What we know now is this is going to be 1/8. Let's just kind of simplify it a little bit. P6 q to the 3. And then we now have over here 16 p to the 4th q 8, like this. Now, how do we write the final answer? We have the numbers 1/8 times 16. If we multiply them together, it's going to be 16 over 8, right? 16 over 8 is just 2. So really the number that you write down in your answer is 2. And then the p's, here we have the p's here, 6 plus 4 is 10. We can add them together because now we're multiplying these guys together, multiplying all these terms. So we add the exponents. P, 6 plus 4 is 10, and then we have q, which is the same base. 3 plus 8 is 11. So q to the power of 11. So the final answer is 2 times p to the 10th times q to the 11th. Lots and lots of ways to make a mistake there. But if you follow the rules very step by step, you will get the right answer. All right, let's go back and do one more. Just one final problem. Our last problem is going to be interesting. What if we have a bracket 2x squared to the power of 2, and then the whole bracket is also raised to the power of 2. Now make sure you absorb what's happening here. You have this monomial here, and you're raising it to a power, and then you're taking the whole quantity that you get as an answer and you're raising it to another power. Okay, that's exactly what that is. So rather than try to guess at what to do, you need to think of your order of operations. Order of operations says, first you do what's inside the parentheses. Now inside these parentheses are, and we go inner to outer, okay? We can't do anything really inside of here. The next step in the order of operations is to do your exponents. But the way to handle it is to apply this exponent into here, get the answer, and then you've basically done, and you would then know what's inside these brackets, then you apply that exponent. So let's go and do the first one first. Let's open the bracket, and then what we're going to have inside is going to be 2 to the power of 2, and x to the power of 4, and then this whole thing is going to be squared. Make sure you understand the 2 gets applied to the 2 as 2 squared, and the 2 gets applied to this term, which means 2 times 2 is 4. That gives us what's inside, and then the squaring is still happening on the outside. We just haven't done it yet. So what we have is, what is 2 squared? It's 4 times x to the 4th power, and then we square it. So now this 2 is going to finally, to get the final answer, be applied to each term here, multiplying any exponents along the way. So 4 squared times x to the what? 4 times 2 is 8. And then ask yourself, what is 4 squared? It's 4 times 4, which is 16x to the 8th power. That's the final answer. So if you ever see something raised to a power and then raised to another power, you just have to go to the innermost thing, do that first, figure out what that final answer is, and then do the outer exponentiation, and you're going to get the right answer every time. So make sure you understand that. Solve this problem for yourself, and then follow me on to the next lesson where we're going to continue and kind of conclude our discussion of powers of monomials.